Michelle Little, and my technology integrated lesson is going to be on nuclear processes. Ideally, this lesson would be given to an 11th grade chemistry class, and the estimated duration would be 60 minutes. So the objective by the end of this lesson would that students would be able to explain the difference between alpha, beta, and gamma decay, as well as describe the characteristics of each. So these are the standards, the next generation science standards, as well as the Common Core mathematics and English standards. So the curriculum addressed in this lesson is that students should be able to understand the difference between alpha, beta, and gamma decay, to be able to complete nuclear decay equations, as well as understand the uranium decay series. The technology addressed in this lesson is the use of Padlet for introductory questions, Google Slides for paired activities, and a end of lesson Kahoot activity. So the only technology required is a Chromebook, access to a Google account, and obviously Wi-Fi. The only other resources that students would need is the links that I would provide in this lesson. Prerequisites that students will have prior to this lesson is background knowledge on the composition and structure of the nucleus, how to use a Chromebook and access the internet, and how to navigate Google Slides. So to begin the lesson, I will just put up a slide of what the students will need to be prepared. Then I will do a simple Padlet to do a recap of the prior day's lesson, having students ask any questions that they still might have, and also to get their minds working. Then I'll do another Padlet asking what you already know about the nucleus, and what do you know about its stability. And then finally, I'll do a Padlet that is asking what do you know about nuclear radiation, and what does that term mean to you? So then I will get into the content of the lesson, and obviously if this was a real lesson, I would have a lot more here, but this is just a brief overview of it. Then this is the first paired activity that is just a simple draw the lines and match the correct term, just as a knowledge checkpoint. Then getting into the uranium decay series, we'll talk about that, and then as pairs, I will have them complete this nuclear equation. And then we'll begin to discuss the potential harmful effects of radiation and of each type of radiation. Then this is just another true-false knowledge checkpoint. And then getting towards the end of the lesson, I will do a think, pair, share, where students first will come up with their own definition for either alpha, beta, or gamma decay. Then, working in pairs, I'll have them come up with a consolidated definition for one of the terms, and then type their answer below, and then we'll discuss, obviously. Then I will go over the homework for tomorrow, which would just be for them to read an article on the next day's content of the next day's lesson, and then complete a journal activity on Seesaw, which I think is a really cool program. And lastly, for fun, we'll do a Kahoot activity, and this will also give me an idea of assessing how far they've come and what they still need to work on. So the student-focused activities of this lesson were the use of Padlet to do the introductory questions, completing activities on Pear Deck for knowledge checkpoints, as well as a think, pair, share, and a end of lesson Kahoot activity. So optional knowledge extension activities is that students could do research on the use of radioactive isotopes, as well as the potential harmful effects of radiation. And as far as the assessment of their knowledge and whether or not they've met the objectives of the lesson, I can review their Padlet, Pear Deck, and Seesaw responses